So, greetings of the day. Myself, Dr. Nidhya, working as professor in Computer Science and Engineering Department, Madanapalle Institute of Technology and Science, Dept University. So, we are going to discuss about the series of lectures on data structures. So, in this particular lecture, we are going to discuss about what is data structure, what are the different types of data structures, linear data structure and non-linear data structures. In linear data structures, we are going to discuss in detail about stacks, queue, and nonlinear data structure, we are going to discuss about the tree and graphs. So first let us enter into the first session of our series. So we are going to discuss today about introduction to data structures. Today our flow of presentation will start with definition, introduction part, classification of data structures, difference between the primitive and non-primitive data structures, first of all. So before we are entering into the session, I want to tell you few facts that is more important related to the subject. You see, data structure is a very important subject that everyone knows. And whether you are expert, you want to be expertise in Java or Python or whatever the programming language it may be, but definitely you must be expertise in the data structures. So whenever you are going with any product-based company, it is a mandatory subject that everyone knows. It's a very relatable analogy that every time I use it to tell in my class. You see, whatever the human may be belongs to whether it is a girl or boy, or it can be an Indian or one US citizen or African, whomever it may be. By seeing a person, you can see me, by seeing my features, you can tell, okay, she is one lady is talking in front of you. Suppose one boy is talking in front of you, by seeing the features, you can tell it is a thing. You just consider one skeleton is sitting in front of you. So, what it will be? Whether can you identify it is a girl or it is a boy? He is belongs to Asian specific area. He or she is belongs to the US, like that. Can you tell anything? It's not at all possible because outer skin may define who are what they are. But you see, the skeleton is same to everyone. Human is a human. Wherever you are belongs to, whatever the gender you are belongs to, you don't have any difference at all. So similarly, whatever the programming language you want to be expertise, it's like your skin and flesh. Whatever you like, you can keep. If you like Java or Python, whatever you want, you can just fix it on it. But the skeleton is going, it is called as a data structure. So it is a very important and core component for any computer science and engineering professional. And why we are having a different data structure? You see, another one analogy I want to tell you. I feel very thirsty. I have a drum of water over here. How can I drink it? I will look for any water bottle or any tumbler or something. I will look for it, right? Suppose I don't have anything at all. What I will do? I will use my two hands to drink some water because I feel so thirsty. Somehow I want to drink the water. So these are the different methodologies or a different thing I will do. So somehow I want to complete the things, right? So can you tell that water is having any shape or something? No, if you are taking one tumbler, it will have the shape of tumbler. If you are going to take the water with the help of two hands, it will take the shape, whatever the temporary shape you are having your hand. Likewise, the water don't have any shape, but according to the container which is going to have, according to that the shape will come, right? So this fits exactly to the data structure. The data don't have any structure at all. It is a kind of information, but where you are going to save it, how you are going to retrieve it, those things it have a certain procedure. According to the procedure it will act. So the data is kind of thing, it will be their static data, that's it. But how to store and how to retrieve and all, the data structure has to define, okay, this is how I have to put the data into the database, and this is how I have to get the data from the database. Those things I have to define. That is called as the data structures. Okay, so with that note we are entering into our today's session. So first of all, what is data? So data is nothing but a collection of raw information, already I told you. So what is data structure? If you ask, the representation of logical relationship existing between individual elements of data. What is that logical relationship? If you ask, that logical relationship is something like how to store, how to retrieve, and how to access the element in that, how to update the things. So those kind of logical operations, what are all the things I can do it in my database? That is called as the data structure. Still, the core specific definition I can tell you in such a way like data structure is a specialized format for organizing and storing a data in the memory that considers not only elements stored but also their relationship to each other. So it's not only saving. Okay, what is the relationship to the next element? So that is also called as the data structures. You see, data structures contains it used to affect the both structural and functional aspects of the program. So how you are telling the functional and structural aspects? So the structural aspect indicates like how to store the data. Like I want to store the data one after another. So this may be one way. Like you are the first one, the next element what I'm going to add will be act as the next element. Like that it can be done. Or else I can do it in another way. What is that? Whatever the element I'm adding, on top of it I will add the next element. On top of it I will add the next element. You see, what is the first element that is added in the database will be in the last. Especially in classroom environment, we can see. I ask the students to submit the records. The first student will submit, the second student will submit, and above the first student record. Likewise, they will submit. And the student who has submitted the last record will be available first for taking the correction. Right? So, in this way, how it is storing in a structural way, and similarly how it is going to act in a functional aspect. So both the things will be typically affected by the data structure. Okay, we are entering into still deep of it. What is the program? So the program, as of now, we are seeing like some coding we are doing. We are giving some data, it is giving the output, right? But it's not a thing. Each and every program is having a certain kind of algorithm followed by one data structure. Every program is implemented based on some data structure. We may not tell what it is, but logically it is connected in that way. Suppose you are using an array. I want to print the multiplication table of the number 10. What I am doing? So, ma'am, it's just a multiplication number you can tell, but there also one particular data structure we are using, that is the array data structure. What array is the data structure? You can ask me. Yeah, it is also a kind of data structure which is already defined in the system itself. In that way, everything what you are using, that part will come again, but still I tell you, each and every program what we are implementing in real time, that will have the typical data structure in it. Okay, and you know that algorithm is a step by step procedure to solve the particular function, and data structures will give you the way to implement. It will give you the typical way to implement the thing. How to solve the procedure will be implemented by algorithm, but how you can do it in a real time will be informed by the data structures part. Generally, the data structure is divided into two major parts. One is the primitive data structure, another one is the non-primitive data structure. So here you go with that. So what is a primitive data structure? Is if you ask me, there are primitive data structure is a kind of data structure. In your system itself, it is having all the things. You know, no need of giving any special kind of program to implement at all. You just do a certain kind of keywords for it. Automatically, that particular data structures will be executed. Say for example, integer, float, character, double. Whether if you are using in a C programming, these things, whether we are defining how the integer numbers should be, how one float number should be there, whether we are defining anything, no. But automatically it is taking how, because it is pre-binded in your compiler itself. So that is called as, that's why I told, whenever you are executing any program along with the algorithm, your data structures plays a major role. Hope you got your answer right now. So this is the reason. Each and everything what we are using in our system, it is predefined part is also called as a primitive data structure. Especially if you have learned Python already, you must have come across with few terms like list, tuple, dictionary, sets, all those things, right? We use it to call those terms as the Python data structures only. Why? Because it having a certain kind of logical things, it is already pre-binded in your interpreter itself. Likewise it is. Let us come to the non-primitive data structure. The non-primitive data structure is divided into two major parts. Actually, we use it only list, but still I want to tell you one more category to you. One is the array, another one is the list. Ma'am, how it will be non-primitive data structure array now? Because array is not generally available. It is a user-defined data type, right? You have to define in such a way like how the array can be accepted in the compiler. So it will be differ language to language, but still the overall concept is same, right? So array, when I want to access a group of elements, similar data items in C programming, I can use it as array. In Java, I can use it in another way, list. And Python, it will be a list. Like that, many types are there, right? So here arrays can be single dimension, two dimension, multi-dimension, anything it can be. So this is also kind of thing which is created by the user. But the typical non-primitive data structure starts here only. One is non-linear data structure, another one is a non-linear data structure. On top of it, I have the linear on lists on it, because both the things can be implemented using the list. So that I have taken the list as the on top of it. We will come to that point later on, not now. Okay, so linear data structure and non-linear data structure. So what is the linear data structure? So generally the term linear indicates like one after another. After one I can access the next, like that it will come, right? So that is called as a linear data structure. Especially I can tell you one example. You consider like some people are standing in a theater queue. How the people will stand? First person who came at the first will be standing in the first. Next will be coming over there. And who will get the first ticket? Definitely the person who comes first only will get the first ticket, right? So likewise, I can, and who will get the next ticket? The person who has come next will get the next ticket. Likewise, they will be getting a ticket one after another. Okay, one got the ticket. Okay, 10th person I will get 1 to 9, you wait. Like that, they won't tell, right? So it will be goes in a sequential order, one after another. Example, printer. You are giving 10 prints at a stage. First has been printed. What will print next? Obviously will be the second page will be printed next, not the third page. I like fifth page, madam. Then you have to print it in such a way like 1, 3, 5 only you print. Once you have given a 10 prints, the print will come in such a way like 1, 2, 3, 4, 5, 6. It won't stop for anything or everything. Maybe total print got struck. It won't skip the elements and it can't go further. So that is the thing called linear. The linear can be implemented in many ways. Stack, queue and all. And non-linear data structures, if you see it, there are two different non-linear data structures are there. One is the trees, another one the graphs. So here the major thing is nothing but that lean trees and graphs, like all the applications I can't access in the same way, right? I want to access all the elements one after another. No, I can't access in that way. One element in some applications, say for example, you are creating one directory in your computer. How the directory will be created? C colon I will open. So in the C colon, consider I have a MITS folder. Okay, I will open the MITS folder. In the MITS folder, I have a BTech, MTech, MBA, MCA. 4 different folders are there. Okay, I will have 4 different folders are there. In BTech, I have 7 departments. All 7 will be there. In one department, in 1 year, in one roll number, I want to go. You see that director will be go drastically in different path. First thing, C folder, MITS folder, and different department. In that, I take a BTech, different programs. In that, I choose a BTech. For under the BTech, many multiple departments are there. I'm choosing a CSE. In that, I'm going one thing. You see, I can't access. You see, no. If you want to come, you go to root and then MITS, then all programs, then only BTech. Like that, I can't tell, right? If you are using a linear data structure, that's the way you have to use. But now I'm not going to use it in that way, so that we are entering into the non-linear data structure. That is nothing but trees and then graphs. So this is what the difference between the linear data structure and non-linear data structure. And see, in primitive data structures, what are the different operations will be available? Na? You can create, you can select, you can update, you can delete. You see, I'm going to create one integer variable. That is what the thing. I want to get the value of that particular integer variable. I want to change the value of that variable. I want to delete the variable. Likewise, I can do a multiple operation on that particular primitive data type, right? So this is what the basic operation we can do on it. So what is the non-primitive data structures? So here the non-primitive data structures which are derived from the primitive data structures only, but still it is having a different kind of actions when comparing to the primitive data structure. It is having a piece of information on it, but it will have a group of same data type or group of different data type. Anything can be stored in this particular part. Okay, and similarly, if you come to the linear data structures, as I mentioned, linear data structures is a kind of data structure that has a homogeneous elements. The data structure is in which elements are in sequential and form linear sequence. That's what I told already. In linear data structure, it's very easy to implement and maintain the memory of it, because all the memory has been organized in a sequential way. So it is very easy to implement, and it is the very easiest data structures comparing to the nonlinear data structure. And what are the commonly used linear data structures? Stack, queue and linked list will be the common thing will be there. And what is the nonlinear data structures? As I mentioned earlier, it is not the sequential connected data. It can be accessed in any order. That is the first and foremost thing. Most probably it will be in a hierarchical relationship or parent-child relationship. Don't worry about the terminologies. When we are coming to the non-linear concept, that time we will discuss in clear. And non-linear data structures may exhibit either in a hierarchical relationship or parent-child relationship. It will be there. And data elements are not arranged in a sequential structure. Example, trees and graphs. Okay, what are the operations I can do on nonlinear data structures? Or non-primitive data structures. If you ask, in non-primitive data structures, we can do the traversal, insertion, selection, searching, sorting, merging, deleting. All those operations I can do it on the non-primitive data structure. It can be an array or it can be a linear or non-linear data structure. Whatever the non-primitive data structures it may be, I can use all this kind of information. Okay. So generally, the primitive data structure is the basic structure which is usually built into the language. That is called as primitive data structure. Non-primitive data structure is nothing but built out of the primitive data structures, linked it together in a meaningful ways such as linked list, binary search tree, AVL tree, graph, and likewise etc. Many things it can be considered over here. And see, in the entire session, we are going to use the two different things. One is the array based, another one is the linked list. Even you have seen, right, in the non-primitive data structure, we have divided the entire structure into two ways. One is the array part, another one is the list part. So in array, when you are going to define an array variable, how you will define? Int a of 10 equal to, I can assign the 10 values. I can assign even a 0 value, maximum of 10 values I can assign. So where I want to add a 11th element, it's not at all possible. So what I will do, I may go for the dynamic memory allocation or something I have to do, right? So in that case, there is a concept called linked list is coming into the existence. In the linked list, I can have the n number of elements that will allocate the memory in a dynamic way. In that way, it will be allocated so that whenever I want to, I don't know how many elements I am going to add. I want to add n number of elements for my process. That time and all I can use the linked list. So in simple words, array is for the static size and linked list for the dynamic size. And there are other more differences also there. And memory is allocated from the stack. So it's obvious when it is array, the memory will be allocated from stack. And here the memory will be allocated from the heap data structures. And it is necessary to specify the number of elements during the declaration itself. Why? Because it is a static one. Here no need to declare, during the declaration no need to tell anything, because during the runtime how many elements you are requesting, that many it can allocate. So that is another one important thing. And you see here the memory occupied for the array is comparatively less to the linked list. Why? Because each and every time when I am going to add a linked list, I am having one node. That node should be connected to other node. So on that case, there should be a connection between one node to another node. So the pointer variable will be coming to the existence. So our next slide itself will discuss about that only. So that time I will tell you. So definitely memory will be more for the linked list. In array, the memory will be little less. And inserting new elements in front is little expensive, quite expensive, not little expensive. You see, I have created an array with an element of 10. Now I want to add one element in first array. What I can do? I have to push the first element to second position, second element to third position, third element to fourth position. Likewise, I have to do. But so it is very expensive because that many shift processes are needed here. But in linked list, it's very simplest one. Only one node I will create. I just put it in front of it. It will act as the first node. So I will show you that one. And deleting an array is not at all possible. Still, I am telling something. What is the deletion is? It's not deletion. I can overwrite the data. Once I created any data in array, it will be there. Only thing what I can do is I can update that particular position with some other data. Say for example, in position 0, I assign the number 10. I don't want 10. Then I can update with the name number 100. Instead of that, I can't delete that element. But in linked list, I can delete the element. So these are all the difference between the array and linked list. But in simple time, I want to differentiate array and linked list. Array is the static and linked list is the dynamic. And so first let us discuss about the list. So list is also called as the linked list. So linked list is nothing but a linear data structure, one of the example. Why it is a linear example means the list element can be accessed one after another. So that's why it is called as one of the linear data structure. It can be defined as collection of variable number of data items together. So here you can see it, right? Here I have the node 30. The node 30 should be connected to node 20. So what it will do, how I can give the connection between 30 to 20, I am giving one pointer variable. So with that pointer variable, the first node is getting connected to the second node. And similarly, I want to connect the third node. So what I will do, the second node's linker is connected to the third node starting. So likewise, it will have the series of element together. It is called as a linked list. So the node will be connected to the next node to form a series of information together. Okay, so how can I know what is the starting of that entire list? Where I am having the head node or the start node, that is known as the starting of the linked list. Okay, and see here that all the information will be presented in terms of the node. What is node? The node contains one data and one reference pointer. That is what called as the one node. So this is a node one. What it is containing one information, and it is containing one link. So that link will give you the address of the next variable. So that is actually pointer variable that contains the address of the another variable. What is that another variable? The next element in the entire sequence. So what are the different types of linked list are there? That is nothing but singly linked list, doubly linked list, and then circularly linked list. Okay. So still that varieties are, what are the different types of things and all, we will discuss in the next class. So in our today's session, what we have discussed is, we have discussed about what is data structures, and we have discussed about what are the different, what is data, what is data structure, that we have given a clear definition. Then we have discussed about the different types of data structures, primitive data structure and non-primitive data structures, and we have discussed about the difference between the primitive data structure and non-primitive data structure, and we have discussed about the list. What is list? List is nothing but a collection of nodes together. Each and every node contains one data and one pointer variable. So the pointer variable which contains the address of another variable. So that we have discussed, and we have started discussing about the list point. There are three different types of the lists: are the singly linked list, doubly linked list, and circularly linked list. So with that, we are closing our today's session, and next session we will discuss in detail about the singly linked list and its operations. Thank you.